Hey guys, in this video we're going to be going over lesson 6.7, which is the first two types of factoring that we're going to do. And I just wanted to remind you of some things before we start this. Number one, I go a little faster in videos than I would in class. It's just awkward to have a lot of silence on the videos. That's because you have the ability to pause it and you have the ability to slow it down. Somewhere there's a settings and you can change the playback speed to like 0.75 and it will slow it down for you. Another thing is when you're watching these, it's important not to just copy down what I write. If you do that, then you're not learning it, you're not understanding it, and you're not going to be able to do it. You've got to treat it like you were sitting in class. When I tell you to pause the video and try it out, you actually need to do that. You actually need to be trying them so that when it comes to practice, I don't know how many times people have said, well, I watched the videos, but I don't know how to do it at all. Well, it's probably because you're literally just watching it. You're not trying it. These things require you to sit down and try them and figure them out. And as we get to factoring, it is going to seem a little harder. So it is important that you really focus and really try. So the first type of factoring is GCF. And you probably recognize the term GCF, greatest common factor. And so with GCF, with just numbers, we look for what's the largest number that will divide evenly into both of those. And that's the GCF. When we have variables, you know, if we look at number one.
Just a reminder, at noon today, site-based election will be in the library. Thank you.
Sorry about that. So on number one here, if we just look at the variables, that 12 has x cubed, meaning he has like 3 x's that he could get rid of. And the other one, 10x cubed, well, he has 2 x's he could get rid of. So when we think about the GCF, we can't take out any more than one of them has. You know, if person A has $3, the other person has $2, they can't pay me more, you know. If I wanted them to pay me the same amount, I could not ask more than $2 because one of them only has $2 to give. So that's kind of the way you need to think about it with GCF. So if we think about 12 and 10, what is the largest number that goes evenly into 12 and 10? Think about it. Try to figure it out. Well, 12, we got 1 and 12, 2 and 6, 3 and 4. In 10, it's 1 and 10, 2 and 5. So the only number they even had in common was a 2. And then for the x's, I can only take 2 of them away because the 10 did not have more than 2 to give. So then we write down what is left. So if I have 12, and I divide that by 2, we're left with 6. And then I only took 2 of his x's, so he still has 1 left. Plus, and then the 10, if I divide that by 2, we get 5. But I took all of his x's, so there aren't any left. So my answer is 2x squared and then 6x plus 5. And 2x squared, that is my GCF. Number 2, we have 14m to the 8th minus 7m squared. So 14 and 7. What is the largest number that goes into both 14 and 7? It's 7. And then m's, I can only take up to 2 away. So 14 divided by 7, that's 2. And then the m's, I still have 6. Minus, what is 7 divided by 7? That's 1. And then the m squareds, I took all of them. So it's 2m to the 6th minus 1. Number 3, we have 27 plus 9x. What is the largest number that goes evenly into 27 and 9? It's 9. And then if I take 27 divided by 9, we get 3. Now, the reason I didn't pull out any x's is because the 27 didn't have any at all. So we couldn't factor out or bring out an x. And then plus 9 divided by 9 is 1, and it still had its x. You could also just write this as 9 times 3 plus x. Number 4, we have 6x to the 5th y minus 4x cubed y to the 6th. So we have two variables, but we're going to do it the same way as we did with just one. So look at 6 and 4. What is the largest number that goes into both 6 and 4? It's 2. Okay, then our x's. The most I could take is 3. And then the y's, that really has a 1 exponent, so I could only take 1. I can't take any more than that. Okay. And then 6, if I divide out the 2, I'm left with 3. And then the x's, I've got 2 left. And the y's, I took all of those. Minus 4 divided by 2 is 2. Now I took all of the x's, but the y's, I still had 5 left. Number 5. Look at your 16 and 8. So 8 is the largest number. Oops, I missed my x's and y's. All right, the x's, the most I can take out is 1. And the y's, the most I can take out is 1. Because this guy doesn't, he only has 1 of each, so he can't give any more than that. Okay, if I divide 16 by 8, we get 2. And then I took all of his x's and all of his y's. Plus 8 divided by 8 is 1. I took his x's, but he still has 8 y's left. Number 6, there are 3 terms, but we don't do it any different. It's still the same. So what is the largest number that goes into 18, 16, and 10? The largest number. It's actually just 2. And then look at the x's. Well, this middle guy, he only has 1, so I can only take 1. And the middle guy also only has 1 y, so I can only take 1 of those. So then 18 divided by 2 is 9. He has 2 x's left and a y left. 16 divided by 2 is 8. And I took all of his x's and y's. Minus 10 divided by 2, that was 5. And he has 1 x and 2 y's left. So that's how you factor by GCF. And a lot of times you will have to factor by GCF, but then there will be something else that you do. So it's really important that you know how to take out the GCF. Let's move on to the other method, which is called difference of squares. And before we do difference of squares, let's talk about some perfect squares. So, what is the square root of 1? 1. The square root of 4 is 2. Square root of 9 is 3. Why don't you try to get a few more? Square root of 16 is 4. Square root of 25 is 5. Whoops. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. We might as well just go up to 10. Square root of 81 is 9. And the square root of 100 is 10. Now, there are more perfect squares than that. That's just the first 10. They're infinity number of perfect squares. But here's something new. We can take the square root of variables as long as the exponent is divisible by 2. Let me bump that down a little bit. You divide the exponent by 2. So if I'm taking the square root of x squared, that is x to the first, which is just x. The square root of x to the fourth would be x squared. The square root of x to the sixth is x to the third, because 6 divided by 2 is 3. What about the square root of x to the 14th? That's x to the 7th. What about the square root of x to the 48th? That's x to the 24th. So when you have a variable and you go to take the square root, you divide the variable by 2. So up here, let's just list those perfect squares that I did there on the side of these numbers. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and if we keep going, 121, 144. So this is a type of factoring, difference of squares, when we have two perfect squares. Let's just call them a squared and b squared. Two perfect squares. They could be numbers, variables, or a combination. Everything is a perfect square, and it's subtraction. That's the important part. It has to be subtraction, because that's the word difference means subtraction. And so when we do these, we're going to take the square root of both sides, and that gives us our a and b. And then we just write our answer as a plus b, a minus b. So let's practice. Number 7. To find my a, I take the square root of the first thing, which is x squared. So what is the square root of x squared? Well, it's just x. And then for my b, I take the square root of the second part. Just ignore the minus, just the number. 64. What is the square root of 64? 8. And so then for my answer, I write x plus 8, x minus 8. And that's it. The only hard part is that when you start these, you actually have to look for a GCF first. Sometimes, not always, but sometimes there will be a GCF. And if you don't take out the GCF, sometimes you can't even get an answer. Or sometimes you could get an answer, but it's not completely right because I want you to factor it completely. So it has to be, everything has to be factored and split up as much as possible. So always look for a GCF. And I should have mentioned that before we started number 7. So number 8, let's look for a GCF. Is there anything that x squared and 49 have in common? No, there's not a GCF. So my A, I'm going to do the square root of x squared, which is x. And my B, that's the square root of 49, which is 7. So my answer, x plus 7, x minus 7. Number 9. Is there anything that those two terms have in common? The answer is yes. They both have some x's in common. So I could factor out some x's, and I can actually take 6 of them. So if I take out x to the 6, that leaves me, if I take out all of these x to the 6, we don't leave it as 0 or blank. We have to put a 1 there. Minus, I still have the 4. I didn't take out any numbers. And I still have 4 x's. So now when we go to do our A and B, we only look at what's left in the parentheses. So my A is the square root of 1, which is 1. And my B is the square root of 4x to the 4th. So when we have multiple things, you just take the square root of each part. So what's the square root of 4? 2. What's the square root of x to the 4th? X squared. So when I factor, I have 1 plus 2x squared, 1 minus 2x squared. But you can't forget your GCF. He has to go down there too. Oops. So my final answer is x to the 6th times 1 plus 2x squared times 1 minus 2x squared. Okay. Number 10, is there anything that those have in common? They both have a 4. So we could factor out a 4, leaving us with w to the 16th minus z squared. And those were totally different variables, so I couldn't take out 2 of one because they're totally different. It's like somebody having apples and oranges, and neither one can give me both. So, different variables, you can't take the GCF. So my A is the square root of W to the 16th, which is W to the what? It's not 4, it's 8. Remember, when you have variables, you just divide the exponent by 2. And my B is the square root of Z squared, which is just Z. So my final answer, we got to bring our GCF, and then we have W to the 8th plus Z, W to the 8th minus Z. So I have this place up here to rewrite our perfect squares just so that you don't have to keep flipping. I'm going to write them really quick. If you want to copy them down, you can. Let's try number 11. Is there anything that those two parts have in common? There's not. Nothing they have in common. So we can just go straight to finding our A and B. So if I take the square root of 25x squared, what is the square root of 25? 5. And the square root of x squared is just x. And my B, the square root of 16 is 4. So my answer is 5x plus 4, 5x minus 4. Number 12, is there a GCF? There's nothing they have in common. I can't divide out a 2, a 3, or anything. So my A, square root of 4x squared, what is that? 2x. And my B, that's the square root of 9y squared, which is 3y. So my answer is 2x plus 3y, 2x minus 3y. Number 13, do they have anything in common? Nope. No numbers, no variables in common. Why don't you try this one on your own? See if you can do it. So for my A, you get x. And for the B, you get 5y to the 4th. So your answer is x plus 5y to the 4th, x minus 5y to the 4th. Hopefully you're starting to get the hang of these. Number 14, is there anything they have in common? Nope, not really. Or not at all. So my A, That's the square root of 36, which is 6. And my b, that's the square root of x to the 100th, which is x to the 50th. Divide by 2. You don't take the square root of the exponent. You just divide it by 2. So my answer is 6 plus x to the 50th, 6 minus x to the 50th. All right, 2 more examples. I know this has been a long video. Hopefully you've stuck it out. So number 15, is there anything they have in common? Yes, you can divide both of these by 5. So that leaves me with 9x squared minus 1. So my a is the square root of 9x squared, which is 3x. And the b is the square root of 1, which is 1. So my answer, I write 5 from my GCF, and then 3x plus 1, 3x minus 1. And number 16, last one. Do they have anything in common? Yes, you can divide both of them by 5 again. So if we divide by 5, we get 4x squared minus 25. So my a is the square root of 4x squared, which is what? 2x. And b is the square root of 25, which is 5. So my final answer, we have the GCF of 5, and then 2x plus 5, 2x minus 5. All right. I hope you have a wonderful day. If there are any questions that you have over this,